Hello everyone! So in this video I want to show you guys my rigid body based player controller. So just a small showcase that this rigid body works just as expected. We can jump, we can walk on slopes. Let's go quickly to, we have stairs here. They are not really stairs, they are also slopes, but you know it's also cool to have this, I guess. Um, we have this big slope. Let me just quickly set the max slope to something kind of small, like 35. And now if there is a slope that we can't climb on, then we just slide it down the slope. Yeah, we can't walk on it. We can move mid-air, but not by a lot. Like if I press like A or D, then I move but a tiny bit. And if I just press, if I just like try to go backwards, then I also can move, but not by a lot. Also, this is a rigid body, so we can completely interact with physics. Like there we go, we push this ball, we push this cube a little. Yep. So this is pretty smooth. Like the character control is smooth. There are no like jumps or things that happen or random bounces that usually happen. Or if you go down the slope, then it's also smooth. There is no time whatsoever that you have to wait. Yeah, so let's get to the code and see how this works inside. I'll try to explain it the best as I can. If something is not very if something's not very understandable, then just type in the comments and I'll try to answer as much as I can. Actually, before jumping into the code, let's look quickly at the different options that we have. So first of all, we have the player camera, which is obviously the player camera, and we use it to orient the body of the player in which direction to move. So for example, if we are the camera and we will be facing towards that direction, we want to tell the player, hey, move to that direction. So we can also see it in the code. We have this rotate body to looking direction, which just takes the y component of the camera's rotation and just sets this as our Euler angles. Okay. Next we have the orientation, which I will be explaining later on. We have the ground mask, which obviously just says, hey, like what is ground? Like if we're standing on this slope, if it's marked as ground or default, because that is the current layer mask that I've set, then we will mark it as ground. And if the player stands on it, he won't fall through and whatsoever. Next, we have the ground check distance, which is the distance down to which we check if the player is grounded or not. Next, we have the jump force, which is obviously the force which we jump up. So this is 12 and I jump this high. And if we set this to something higher, like 25, then I obviously jump a lot higher. Well, and next up is the max jumps, which is kind of self-explanatory. I've also showed it. So if we have 12, I can jump once. If we set the max jumps to something else, like 5, then I can jump now 5 times in a row before I can not do anything else. So let's just count to see that I'm not like crazy or something. 1, 2, 3, 4, 5, and I cannot jump anymore. So this works correctly. And next up we have the walk force, and this is the force which we use to move the player. So for example, what could be a good example? Let's go back to the slope that we slid because it was too much of an angle for us, like here. And let's set the max slope to like 35. So now I can't walk up the slope, right? But if I set the walk force to about 250, I won't be able to walk, but the force which that we're applying to the player is largest. So we won't slide down at the start, but maybe we'll get a little bit further, just a little bit further, just like you saw right now. So we get a little bit further. Anyways, it's the force that we use to push the player with around the map, just to move the player. Next up, we have the walk speed, which actually is not the walk speed, but the maximum walk speed. So right now it's 5.5. We can set it to something lower like 2, and now we move slower. Also self-explanatory, not going into how this works currently. We'll get into the code later. And then we have the air movement multiplier, which is the multiplier which we apply to the force when the player is in the air. So for example, if I move right or left like this, it's all good. However, if I try to move right or left while in the air, then I'm going to apply a lot less force. And this is what this multiplier is for. Next up is the friction. So right now I set friction to 20 because 20 friction feels pretty good. We can set it to something lower like 10, and now the player will slide a bit more. Or look to 5 maybe. And now it will slide even more. We can even set it to 1 and then watch the player really slide. Maybe set this to a bit less. So yeah, we can see that this is the friction. You can set it to whatever you want. Next up is the minimum velocity, which is the minimum velocity that the player needs to move. If the player is at a velocity which is less than 0.5, then he instantly stops. Also, not going to go deeper into that. Next up, we have the max slope angle, which we already saw in action, which sets up the maximum degrees of a slope that we can get into. So I don't know how much degrees is that, but we can walk up the slope. However, if I set the max slope to 5, then now we can also go up. Let's set the where is it? Walk speed, which should be the max walk speed, to a little bit higher. Set the friction a little bit higher. So now we can walk this, but we can't climb whatsoever. Next up, we have the slope rail length. And I will be explaining what is that and how we use that in the code. And down below we have anything that is gravity related. So I've added a gravity multiplier which always applies, and basically what it does is it multiplies the gravity that is going to be applied to the player. The reason I do this is because if we set this to 0 and we try to jump, then Unity's gravity feels very floaty, in my opinion at least. So what I did is I included the gravity multiplier, which we can set, and that is the extra amount of gravity that will be added to our rigid body. So I found that keeping it at 1 gives pretty nice results, and I liked it, so I kept it at around 1. You will be able to change it to whatever you want, I guess. And next up we have the extra gravity and the extra gravity time after slope, and we will be seeing what those two values do in our code. So after we've skimmed over the settings, let's jump into the code and see all of these in action and explain what I did not explain here, which is extra gravity time after slope, and the slope rail length and the orientation. Okay. So let's start with the extra gravity time. And to understand actually why we need this, I'm first going to show you. So if perhaps I'm going to go on this slope right now, then everything works good and nice. However, if we set the extra gravity to 0, and I'm now going to go up the slope, well, you see that my player kind of jumps. He like hops off and it takes him time to land back. And if we set the max speed to something higher like 9, then this is really gonna show. Like, this is basically just floating up in the air, and we don't like that. We do not want our player controller doing that, because it just feels kind of unnatural to us humans that when we can like just put one leg here and one leg here and step up. So what I did to fix this issue is basically whenever we are on a slope, I'm going to apply extra gravity to the player. And this is defined by the extra gravity value right here. However, we have the extra gravity time after slope. And we're going to apply this value, apply this gravity, only if we are not grounded and on a slope. Like we're going to only to apply this value if we were just on a slope and we exited it. So for example, if we were to jump off, this extra gravity would kick in for 0.2 seconds. And we would not really feel it too much because, well, Unity's gravity is a little floating, although we added this gravity multiplier and it's for a very short time. But for moments like this, when we just cross this edge and our player has a certain velocity, we want to keep him grounded. We do not want to let him like float around and do like he's a race car and he's flying off into the moon. So let's do the same. We have now the extra gravity set to our default, and I'm going to set the walk speed to 9 like it was before. And if we were now to walk in on the slope, we still have this little bounce, but it's much, much, much less visible to the player than it was before. And this is what the extra gravity is for. Next up, we have the slope rail length, which is right here. And this is used by the extra gravity to detect if the player right now is on a slope or not. This is basically the distance from the feet of the player, which is just here at the bottom of the capsule. It's the distance of the ray, which we're going to cast down from the player to see if he is grounded. And well, if he is, then and he is grounded and not on a slope, and if he just exited within the time frame of 0.2 seconds, then we will apply the extra gravity to make sure that the player is grounded. Okay. Next up, we have the orientation in the camera. So let's start with the camera because it is a little bit easier. So the camera is a pretty standard script. All we do in the camera is we just rotate the player, and I mean not the player. We just rotate the camera, and well, that's all. Nothing else is in here. I did include a function to get the horizontal rotation of the camera, just because I'm using it in the controller script to rotate the body of the player towards the direction in which we are looking at. So it seems like I do not have much time on this video, so in the next part, which I will be uploading right with this one, we're going to look into the code of the player controller and understand how it works, and we're also going to look into the orientation and why we need this. So see you in a second, I guess.